In our C# tutorial, now let's take a look at classes and objects. Classes. As we have seen in the previous modules, built-in data types are used to store a single value in a declared variable. For example, int x stores an integer value in a variable named x. In object-oriented programming, a class is a data type that defines a set of variables and methods for a declared object. For example, if you were to create a program that manages bank accounts, a bank account class could be used to declare an object that would have all the properties and methods needed for managing an individual bank account, such as a balance variable and deposit and withdrawal methods. A class is like a blueprint. It defines the data and behavior for a type. A class definition starts with the keyword class, followed by the class name. The class body contains the data and actions enclosed by curly braces. The example is class bank account, and in the curly braces, it's got a comment that shows this is where your variables and methods will go. The class defines a data type for objects, but it is not an object itself. An object is a concrete entity based on a class, and is sometimes referred to as an instance of a class. To use custom data types, you need to define a class. Objects. Just as built-in data type is used to declare multiple variables, a class can be used to declare multiple objects. As an analogy, in preparation for a new building, the architect designs a blueprint, which is used as a basis for actually building the structure. That same blueprint can be used to create multiple buildings. Programming works in the same fashion. We define or design a class that is the blueprint for creating objects. In programming, the term type is used to refer to a class name. We're creating an object of a particular type. Once we've written the class, we can create objects based on that class. Creating an object is called instantiation. An object is called an instance of a class. The process of creating objects is called instantiation. Objects. Each object has its own characteristics. Just as a person is distinguished by name, age, and gender, an object has its own set of values that differentiate it from another object of the same type. The characteristics of an object are called properties. Values of these properties describe the current state of an object. For example, a person, or an object of the class person, can be 30 years old, male, and named Antonio. Objects aren't always representative of just physical characteristics. For example, a programming object can represent a date, a time, and a bank account. A bank account is not tangible. You can't see it or touch it, but it's still a well-defined object because it has its own properties. Let's move on and see how to create your own custom classes and objects. Which of the following determines the current state of an object? Its properties. All right, let's go over value and reference types. Value types. C# has two ways of storing data, by reference and by value. The built-in data types, such as int and double, are used to declare variables that are value types. Their value is stored in memory in a location called the stack. For example, the declaration and assignment statement int x equals 10 can be thought of as, and you see this image right here that's a stack, the value is 10 and x is pointing to it. So the value of variable x is now stored on the stack. The area in memory that stores the contents of a value type is called the stack. Now we're going to go over reference types. Reference types are used for storing objects. For example, when you create an object of a class, it is stored as a reference type. Reference types are stored in a part of the memory called the heap. When you instantiate an object, the data for that object is stored on the heap, while its heap memory address is stored on the stack. That is why it's called a reference type, because it contains a reference, which is the memory address, to the actual object that's on the heap. As you can see, the P1 object of type person is on the stack, stores the memory address of the heap where the actual object is stored. So here on the stack you see, when you see x equals 10, 10 is on the stack and x is pointing to 10. But when you create a person object, you create P1, person P1 equals new person. P1 has an address. That's what you see, the 0x042b8. That's like an address that points, the address of that object is on the stack, and the address points to the person object which resides on the heap. Stack is used for static memory allocation, which includes all of your value types like x, whereas the heap is used for the dynamic memory allocation, and dynamic means like changing, which includes custom objects that might need additional memory during the runtime of your program. So you may make changes on the person object. Which memory is used for dynamic allocation? That would be the heap. Let's go to a class example. Let's create a person class. Class person. In the body of class person, we have int age, string name, and public void say hi. In the body of the say hi method, we have console.writeLine hi. The code above declares a class named person, which has age and name fields, as well as a say hi method that displays a greeting to the screen. You can include an access modifier for fields and methods. Fields and methods are called members of the class. Access modifiers are keywords used to specify the accessibility of a member. A member that has been defined public can be accessed from outside the class, as long as it's anywhere within the scope of the class object. That is why our say hi method is declared public, as we are going to call it from outside of the class. You can also designate class members as private or protected, and this will be discussed in greater detail later in the course. If no access modifier is defined, the member is private by default. Fill in the blanks to create a class called car. Class, car, opening curly brace, string color, int year, closing curly brace. Example of a class. Now that we have our person class defined, we can instantiate an object of that type in main. The new operator instantiates an object and returns a reference to its location. So again, we're going to remind ourselves what the class looks like. Class person, and in the body of class person we have int age, string name, public void say hi, and in the body of the say hi method we have console.writeLine hi. Now we're going to go to our main method somewhere in the C# code, and we're going to do something with our person class. So inside of our static void main string args, we are going to have person, which is the name of the class. We're going to give it a little object name, P1 equals new person. Now that we've created an object of the person class and it's called P1, we're going to use that P1, a dot operator, and call the say hi method from inside of the person class. So P1.sayHi, that's going to output the word hi to the console. The code above declares a person object named P1 and then calls its public say hi method. Notice the dot operator that is used to access and call the method of the object. Fill in the blanks to create an object of type car and call its horn method. Car C equals new car, and then using that C and a dot operator, call a horn method. Example of a class. You can access all public members of a class using the dot operator. Besides calling a method, you can use the dot operator to make an assignment when valid. For example, We're going to look at a class called dog, class dog. In the body of the class dog, we have public string name and public int age. Those are the only two things, the only two members right now that belong to the class dog. So now when we go into our main method, somewhere inside of the C# code, static void main string args, when we go inside of that method, we are going to say dog Bob equals new dog. Then we're going to use bob.name equal to the string Bobby in double quotes, and bob.age equals 3. Then when we use console.writeLine parentheses bob.age, we're going to see an output of 3 to the console window. Now they want you to assign 7 to the age property of the object. So dog D equals new dog, D dot age equals 7. Let's look at encapsulation now. Part of the meaning of the word encapsulation is the idea of surrounding an entity, not just to keep what's inside together, but also to protect it. In programming, encapsulation means more than simply combining members together within a class. It also means restricting access to the inner workings of that class. Encapsulation is implemented by using access modifiers. An access modifier defines the scope and visibility of a class member. Encapsulation is also known as information hiding. Encapsulation allows you to hide details of a class realization. C# supports the following access modifiers: public, private, protected, internal, and protected internal. As seen in the previous examples, the public access modifier makes the member accessible from outside the class. The private access modifier makes members accessible only from within the class and hides them from the outside. Protected will be discussed later in the course. Which one is not an access modifier in C#? Closed. Private, internal, and protected are access modifiers. Closed? No. To show encapsulation in action, let's consider the following example. Class bank account. In the body of the class bank account, we have a field, private double balance equals 0, and then we've got 3 methods. Public void deposit with one parameter called double N, and in the body of the deposit method we have balance plus equals N, which means again balance equals balance plus N. Then we've got another method, public void withdraw with one parameter double N, and then in the body of the withdraw method we have balance minus equals N, which means balance is equal to balance minus N. Lastly, we have another method called public double get balance, and there is no parameter inside of get balance, but in the body of the get balance method we use the return keyword because we want to return the value of balance. We used encapsulation to hide the balance member from the outside code. Then we provided restricted access to it using public methods. The class data can be read through the getBalance method and modified only through the deposit and withdraw methods. You cannot directly change the balance variable. You can only view its value using the public method. This helps maintain data integrity. We could add different verification and checking mechanisms to the methods to provide additional security and prevent errors. In summary, the benefits of encapsulation are to control the way data is accessed or modified. Code is more flexible and easy to change with new requirements. And change one part of code without affecting other parts of code. Fill in the blanks to declare a person class, hide the age member, and make it accessible through the getAge method. So let's create our class person. We've got private int age, so that's private. Then we're going to use public int getAge, where we're going to return the age. Then we have public void setAge with the parameter of int n, and then in the body of the setAge method, we are going to take age. We're going to have a variable there, age equal to n. All right. Now it's time to look at constructors. A class constructor is a special member method of a class that is executed whenever a new object of the class is created. A constructor has exactly the same name as its class, it is public, and it does not have any return type. For example, class person, and in the body of the class we have private int age. We have public person, this is a constructor, with no parameters, and we have console.writeLine, hi there. Now, upon the creation of an object of type person, the constructor is automatically called. So when we go into our main method, static void main string args, person p equals new person, without doing anything at all, without saying p dot anything, just by creating person p equals new person, we're going to get an output of hi there because of that constructor. It's going to automatically execute. This can be useful in a number of situations. For example, when creating an object of type bank account, you could send an email notification to the owner. The same functionality could be achieved using a separate public method. The advantage of the constructor is that it's called automatically. When is the constructor called? When a class object is created. Constructors can be very useful for setting initial values for certain member variables. A default constructor has no parameters. However, when needed, parameters can be added to a constructor. This makes it possible to assign an initial value to an object when it's created, as shown in the following example. Okay, let's look at the example. Class person. Inside of the class person, we have private int age, private string name, and here's a constructor, public person, and here's a parameter, in the parentheses, string nm. And then in the body of that constructor, we have name equals nm. All right, then we have a method for class person, public string getName, and in the body of the getName method, we are going to use return, keyword, and name. So we're going to return the value of name there. So we've done a couple of things here. We have a couple of fields, age and name. We have a constructor where we set name equal to nm. And we also have a method, getName. So in our main method, and someplace else in the C# code, static void main string args, we take person p equal new person, and we are going to put an argument. Since our constructor had one parameter, string nm, we are going to put an argument in this new person, which is going to be David. Then when we use console.writeLine, in parentheses p.getName, it's going to output the name David on the console window. So now when the object is created, we can pass a parameter that will be assigned to the name variable. Constructors can be overloaded like any method by using different numbers of parameters. What is the output of this code? Class dog, public dog, console.writeLine 1. Okay, so that's one constructor. Here's another constructor, public dog, with a parameter string name. What that is going to do is console.writeLine name. And then when you go into the main method to actually create an object of the dog class, we have, in the main method, we have dog D equals new dog, and we have the string 2 inside. So what's the output going to be? Let's see. The first public dog has no parameter. Nothing in the curly braces. I mean, nothing in the parentheses. The second constructor does have a parameter in the parentheses, and it's a string data type. And when we called dog D equals new dog, because that 2 is enclosed in double quotes, that actually makes that 2 a string data type, not an integer like you would think. Therefore, we are going to be accessing that constructor, public dog string name, console.writeLine name. Well, we've decided that the name is going to be 2, which doesn't make sense, but that's what the code does. It's not a number 2. Enclosed in double quotes means it's the string 2. Okay, let's go over properties now. As we have seen in the previous lessons, it is a good practice to encapsulate members of a class and provide access to them only through public methods. A property is a member that provides a flexible mechanism to read, write, or compute the value of a private field. Properties can be used if they are public data members, but they actually include special methods called accessors. The accessor of a property contains the executable statements that help in getting, reading, or computing, or setting, writing, a corresponding field. Accessor declarations can include a get accessor, a set accessor, or both. For example, class person. Let's look at what's in the body of class person. We have private string name, that's a field. Then we have public string name, that's a property. And so inside of this name property, we have a get and a set. In the get, in the body of the get, which means in the curly braces for the get, we have return name. Then for set, in the body of the set, we take name and we set it equal to value. So that's what the public string name property does. It gives us a get and a set so that we can handle the private name field of this class. So the person class has a name property that has both the set and the get accessors. The set accessor is used to assign a value to the name variable, and the get is used to return its value. Value is a special keyword which represents the value that we assign to a property using the set accessor. The name of the property can be anything you want, but coding conventions dictate properties have the same name as the private field with a capital letter. Which of the following are accessors? Get and set. Once the property is defined, we can use it to assign and read the private member. So again, let's go over the class person really quick. It's got a private string name and it's got a public string name. As you can see, the private string is lowercase name, the public string is uppercase name, and we've got get, which has curly braces that say return name, and we have set, which has its own curly braces that say name equals value. And notice it's using the lowercase version of name, which is private. So now when we look at our static void main string args method, inside of this main method we have person P equals new person, P dot capital name equals Bob, and console.writeLine p.capital name. So here we set the name to Bob, and then we wrote it out on the console by using p, the dot operator, and the capitalized name, which is a public property. The property is accessed by its name, just like any other public member of the class. Fill in the blanks to define valid get and set accessors for the age member. So here we've got class dog with the private int age and the public int capital age. Well, we want to get. With the get, we are going to return the private age, and for the set, the private age is going to be equal to value. Any accessor of a property can be omitted. For example, the following code creates a property that is read-only. So here, for our class person, we have private string lowercase name and public string uppercase name that only has a get. So you can't set it, you can just get it. And the get, of course, has the body return name. A property can also be private, so it can be called only from within the class. Skipping which accessor creates a read-only property? Well, we want to skip the set because we don't want to allow the user to do anything to it. We just want them to read it, which is get. So we want to skip the set accessor. So why use properties? Why not just declare the member variable public and access it directly? Well, with properties, you have the option to control the logic of accessing the variable. For example, you can check if the value of age is greater than 0 before you assign it to the variable. So we'll show you that with this. Here we've got our class person again, and in the body of the class, we've got our private int age equals 0. Then we've got our public int age, which is capitalized. And in our public int age, our get, the body of the get says return age. The body of the set has an if condition that wants to make sure that before you set anything, you check something. This is a way to protect your code and make sure strange bogus values are not set. So inside of the body of our set here, we've got the if condition, if, and in the parentheses, value is greater than 0. Well, if that's true, then and only then will age be set equal to value. You can have any custom logic with get and set accessors. Fill in the blanks to create a read-only property X. The return value of the accessor should be the square of X. So let me read this again. Fill in the blanks to create a read-only property capital X. The return value of the accessor should be the square of lowercase x. Okay, so class A, private int lowercase x equals 8, public int uppercase x. We want to make it read-only, so we're just going to use get, the get accessor. And the return value should be the square of x. So we're going to return x times x. Auto-implemented properties. When you do not need any custom logic, C# provides a fast and effective mechanism for declaring private members through their properties. For example, to create a private member that can only be accessed through the capital name properties get and set accessors, use the following syntax: public string capital name, and in the body of this particular property we just have get semicolon set semicolon. Nice and simple. As you can see, you do not need to declare the private field name separately. It is created by the property automatically. Name is called an auto-implemented property. Also called auto properties, they allow for easy and short declaration of private members. We can rewrite the code from our previous example using an auto property. So here we've got our class person, public string, capital name, and in the body of that we have get semicolon, set semicolon. And then in our main method, we have person P equals new person, P dot capital name equals the string Bob, console.write line in parentheses P dot capital name. That will output Bob. Fill in the blanks to create an auto property named age of type int. So we've got our class dog, public, it says that it has to be type int, so public int age, get, semicolon, set semicolon. So there's an auto property. All right, now we're ready for our Module 4 quiz. Objects of a class are stored on the, remember we're talking about objects, they're stored on the heap. Fill in the blanks to instantiate an object of the class cat, passing to the constructor the value 12. Then call the meow method for that object. Cat C equals new cat. And let's see, passing to the constructor the value 12. So cat C equals new cat 12. We're passing that value. And then we want to use the object, which is C, and the dot operator to call the meow method. To make a member of a class accessible from outside the class declaration, you should declare it as public. Which statement is true? An object is a method of a class, an object is an instance of a class, or an object is a member of a class. It's an instance. An object is an instance of a class. Fill in the blanks to declare a class student with one public method called hello. The hello method displays hi to the screen. So we're going to create class student, one public method, so we're going to use the public access modifier, public void hello, console.writeLine hi. Fill in the blanks to declare a constructor that has one parameter and assigns it to the age member. So in our class dog, we have private int lowercase h. Then we're going to create public dog by val, and age is going to equal value. Uh-oh. Fill in the blanks to declare a constructor that has one parameter and assigns it to the age member. Alright, I'm getting something wrong. Age is equal to Wow, I was getting confused. All right, so class dog has private int age, public capital dog, int val is the parameter, and then in the body of that public dog property, we take age and we set it equal to that age, the one parameter, age equals val. Okay. Which accessor is used to read the value of a member? That's get. Alright, so we've finished our classes and objects. The next video will be on arrays and strings.